I'm Tim Ventura from AmericanAntiGravity.com, and I'm speaking today with David Sereda. Now, David has a diverse background as an environmentalist and clean energy advocate, artist, photographer, and an expert on UFOs. He's also part of the Hollywood community, so I'd like to start out with a question about how Hollywood portrays propulsion concepts in UFO genre and space genre films. How is their vision so apparently out of touch, even with simple physics, David?
Well, when you see, for example, Star Wars, the new Star Wars, or any of the Star Wars, and you see these warp drive systems, it's almost laughable, but it's fun, to watch these guys, their heads go back and they jet out into space. But a propulsion, an ion nuclear propulsion drive that fires out, highly charged nuclear particles that say you can get them to go out at even 99% the speed of light, and that would take 1 trillion electron volts of energy, which today there are no nuclear fuels that can produce energy levels that high. If you could, and you instantly accelerated to the levels that, say, the Millennium Falcon does in Star Wars, the drive itself, the ion drive, would just punch a hole and tear the ship apart, because the metal, the steel and the structure of the craft couldn't survive the sudden pulse and force. And further, the G-forces, even at 1/10 the speed of light, you're doing 67 million miles an hour. There are non-radioactive nuclear fuels like helium-3 that can produce 1/10 the speed of light, and that is 18 million electron volts of energy from helium-3 fusion. In 1989, I had a conversation with NASA's head of propulsion power and energy, Dr. Earl Van Landingham, and he was interested in this particular type of fusion using helium-3 that I was, an associate in working with, because of the fact that we could build ion drives that could gently accelerate up to those velocities. Now, at that velocity, even small arcing turns, just to avoid oncoming, planetary bodies or, meteorites, asteroids, the G-forces will kill you. They'll destroy your craft, and you won't survive. So when you see Lucas's films also, you see these ships, racing into atmospheres. They don't experience any, burn or resistance like the shuttle does when it comes in. They just seem to defy all the laws of physics. And further, his thruster engines on the back of these enormous ships do not explain the anti-gravity concept at all. They just kind of have it assumed.
Oh, sure.
So really, it's fun to watch, but I've personally tried to approach industrial light and magic about introducing them to concepts of how you can, in my theory, wave transform mass to reduce the mass gravity effect. And once you can reduce the mass gravity effect of a craft down to zero, you can do sudden acceleration to light speed and beyond on much smaller amounts of energy because your mass is zero, and you can make banking turns like the way UFOs exhibit themselves. They make sudden stops, right-angle turns, sudden accelerations, and disappear. All of that kind of physics can be explained only by coining the term reducing the mass gravity effect theory that I have put forward.
Yeah, well, I think if it's done correctly, integrating real physics and breakthrough physics into the Hollywood medium can produce much more meaningful results.
And people would have more fun with it. I think if they saw this stuff and the Hollywood community spent the time to, look at AmericanAntiGravity.com and look at Hutchison Effect and your work and all the work posted there and mine, they would have a lot of fun with it. It would just be a better visual for the audience, and the audience could participate in this breakthrough propulsion physics approach.
Well, the one that comes to mind is Mission to Mars. At the end of the movie, that was a Brian De Palma film, and the rumor was that it was actually based on some of Richard C. Hoagland's work. But at the end of the film, one of the protagonists, Gary Sinise's character, gets into the alien spacecraft and it fills up with liquid. And that struck me as incredibly meaningful because a lot of people asked, what was that liquid? What did it mean? And to anyone who read Pulp Fiction from the 30s or 40s, they would know that's a crash couch. It's a liquid-filled chamber, and in his case, apparently breathable liquid. I thought it was a really nice touch on the end of that film.
Yeah. At least it's showing a new idea that could solve one of the, for example, liquid would help you with G-forces for sure.
Yeah.
But it would also increase the overall mass of the ship, so when it made a turn, it would be very, very difficult structurally to hold even the liquid inside of itself.
Well,
But that's basically where Hollywood is. They're to me they're kind of like a cell that closes itself down will eventually entropy. You have to open up more to the community and ask questions. I mean, they should be coming to us and saying, "What's new? What can we learn from you?" They never attend these UFO conferences. They're kind of just like their own island, and I would like to open them to some of the new phenomena that are occurring in the UFO movement and in anti-gravity. And with my new film, Dan Aykroyd Unplugged on UFOs, which is coming out, will be in Blockbuster and everywhere in the next, 2006. I hope people, get a look at this film and see what's really happening in the movement.
absolutely. Now, a lot of the research that you've done over the past years into UFOs has led you in this unique direction to the physics behind it, which I think is really admirable. I think a lot of people tend to get lost in the metaphor and the concept of what ETs are doing, and both of those are valid concepts, but I think we really need to solve the transportation issues. And I think the UFO NASA footage that you were able to put up in the Ackroyd feature is a perfect example of looking to possibly real life, things that are flying around in our skies that are unexplained, to tell us how we can build the transportation solutions of the future.
Well, that's the ultimate. It's like when Da Vinci saw a bird fly, he, started designing a man-winged aircraft, the birth of, the first concepts of how human can fly. And, when I'm standing on the ground in Berkeley in 1967, I was born in 61, on my way home from elementary school, my friend Tommy and I saw a huge crowd of people pointing up in the sky, and we just followed their direction of sight, and there's a UFO. It's a metallic, disc-shaped craft hovering silently, no thruster engines like you see in Lucas's films, silent, and just little wavelets. You could almost see like spinning kind of waves strobing around it, and it's definitely metallic. And it's, if we had video cameras in the 60s like we have today, that sighting lasted for over 20 minutes. I would have had the best video footage and the closest footage of a major sighting over a major city in the whole UFO movement.
Sure.
And, it's kind of like an impression in my mind. I replayed that day from the moment I saw the UFO over and over and over, because I knew back then, I watched Star Trek, I knew what spaceships were, I knew what airplanes were. My stepfather, David Cooper, was in the military, and, I understood all this stuff. And I knew what I was looking at was not of this world. But that's what led me on my chase. I started analyzing video footage of UFOs, and then I got into looking at, Martin Stubbs, program manager of a cable TV station in Vancouver, through a mutual friend, approached me with real NASA video footage, taken with the shuttle's low light sensitive and ultraviolet sensitive and infrared sensitive video cameras that were capturing, clearly what appeared to be UFOs. I spent 6 years at NASA in dialogues with their top scientists, finding out about these cameras, why was NASA looking in the invisible, and, then I started noticing, well, a lot of them, most of them are pulsing. You see this light pulsing, and sometimes you can see a very strong pulsing, just like the shimmering waves I saw around the UFO in Berkeley. Now, the UFO I saw in Berkeley, after 20 minutes, it disappeared in a blink of an eye. It went invisible. That's another reason why I became so obsessed with the invisibility factor in the UFO phenomenon. So when I looked at the waves frame by frame, and my background was, supporting and working with physicists in nuclear fusion. I had been around people like Glenn Seaborg, Murray Gell-Mann, Dr. Bogdan Magwitch from MIT, who were all developing, and supporting Magwich's developments in helium-3 fusion. And, I had to do a crash course just to be a representative of the project and doing fundraising for the project to understand physics and, the science of nuclear energy. So I read almost every book I could get my hands on, and particle physics, the study of, the subatomic smashing of atoms in these particle accelerators and looking at the wave particle motions of the different subcomponents of the atom, you can pretty much tell just from looking at trails that particles leave in their wave formations what they're doing, what the name of the particle is, just by looking at it. And when I looked at the waves on the NASA UFOs, it was like reading particle physics. I knew what they were doing right away. I knew the waves were in a progressional spiral. They were not in a stable state, that they were transforming. What I could see is they were increasing the frequency of mass, which mass today is calculated at almost zero in frequency, because you have a time forward or a proton, positive spinning particle, and then you have an antiproton spinning the opposite direction, and those two forces cancel each other out to zero, supposedly zero. Now, the electron does the same. You have an electron and anti-electron pair, and they cancel out to zero. So most physicists do not believe that matter in its current state is magnetic or electromagnetic, although there is the exchange of electromagnetism and the electron, which is the photoelectric effect, but there is still no overall electromagnetism in the atom because these pairs cancel each other out. Now, when you look at a Niels Bohr model of a hydrogen atom, you see that, the electron sometimes makes deviations in its shell or radial distance from the center of the atom. And when an electron goes into a closer or tighter radial distance from the center of the atom, it is increasing in frequency and therefore gives off its energy in the form of electromagnetism. Now, in an Einstein formula, if you give up your energy, you're giving up your mass, or you're reducing your mass gravity effect. But it's such a small deviation, because when the electron jumps into a tighter shell and the atom gives off its energy, very quickly the electron will jump back out to a further distance, and it will gain back the energy it lost. So what it shows is the atom is slightly quivering. It's so microscopically unstable, in that these adjustments of gaining mass and losing mass are so small that no one thought anything of them. But when you see wave particles making radical, what it actually looks like when a particle spirals to or changes its orbit from a longer or wider radial wave, wave diameter, to a tighter wave, is you'll see a spiral. And then when it stops in its new position, you won't see the spiral anymore. You'll just see the wave. Now, if it's radically transforming from a lower frequency state to a higher frequency state, you'll see a long spiral, a Fibonacci spiral. And when I looked at the waves in the NASA UFOs, these 3-mile wide translucent discs of light, you could see a radical shift in the wave. The wave is very clearly a large ring in one frame of the video. The next frame of the video, you see a smaller ring, so that means an increase in frequency. And then you see this Fibonacci spiral spiraling all the way to the center of the wave generator in the craft. And that means a massive transformation and reduction of the wave. Increase in frequency means a reduction of the mass gravity effect. And then if you look in particle accelerators, you'll also find from these collisions that the particles of the least mass, and in these collisions at 99% the speed of light, 99.99% the speed of light now, with a trillion electron volts and greater, the lowest mass particles, such as the electrons, spiral in the smallest orbits, therefore have the highest frequency orbits, and the particles that are greater mass have the longer curves. Some of them almost look like straight lines, but they're not really straight lines. They're just really long curves. So you find out the heavier the mass the particle at the speed of light collision, near speed of light collision, has a longer wavelength, therefore lower frequency, and the smaller the wavelength and the tighter the spiral, the lower the mass of the particle. So the heavier mass particles have longer wavelengths, the smaller the mass particles or lower mass particles have shorter wavelengths. So that starts to tell you something. When you start to increase the frequency of mass, it has to give off its mass, reduce its mass gravity effect. So then, when you apply that to the concept of, we know that Einstein's law prohibits mass from attaining the speed of light because of the increased mass law. The faster you go, the more inertia pushes on you, and the heavier you get, and eventually when you approach the speed of light for any spacecraft or subatomic particle, you start pushing against the entire mass of the background of the universe, which means it takes an infinite amount of energy to get to 99.999%, and the more you increase the energy, the 9's at the .999 and just keep going towards infinity. You never reach 100% because it will take all the energy in the universe to push against and move the background of the entire space medium, and no one can do that. And
Well,
Einstein proved it.
let's
But
back up for.
but if you reduce the mass gravity effect by increasing the frequency of the wave state of matter on the atomic level, matter actually almost resembles light. You're reducing the mass gravity effect, and once it's near zero, I don't believe in absolute zeros anywhere. It can accelerate much more easily towards the speed of light and beyond.
Sure. Well, let's back up for just a second. For the audience sake, your website URL is www.ufonasa.com, where you're selling a copy of the documentary entitled Evidence, The Case for NASA UFOs, featuring Dan Aykroyd and selling for $24.95. Now, the paper that we're discussing at the moment is entitled Advanced Aerospace Propulsion, a New Theoretical and Experimental Approach, and I have a PDF copy of that online at American Anti-Gravity. And this is really the basis for the galaxy clock theory that you've unveiled, which is really what suggests how a spacecraft can reduce its mass to zero and consequently travel faster than light.
Yeah, that's correct. And the next thing, the reason I created what I call the galaxy clock is because I found there was no model to measure wave-particle relationships in all visual three spatial dimensions plus time, the fourth dimension. And I found that very disturbing. And also that when Einstein puts any model in his four dimensions, up and down, sideways, width, and the depth, and then the fourth is time, I noticed that he didn't include the fact that everything in those four dimensions is in a wave-particle relationship. Everything is spinning. You take the position of any person on Earth and you follow it over time, it leaves a spiraling trail from the orbiting movement of the Earth, which then has a secondary wave that it moves through, which is the annual rotation around the Sun, and then the Sun and in the solar system are moving in a wave formation around the galactic core every 250 million years. So on a galaxy level, planets are moving through waves, and those waves sometimes have enormously long periods, such as a galactic wave. The solar system moving around the galaxy, it will peak. You'll have one oscillation every 250 million years. Now, when you get down to the atom and smaller, particles move through these wave patterns the same way. But we look at wave particles on two spatial dimensions. On a flat sheet of paper or on an oscilloscope, you just see a line bobbing up and down. That's only width and height, which is only two of Einstein's dimensions plus time. And I think that's wrong. I think that if we're going to look for the graviton, the missing particle in physics, and we're going to understand the Big Bang and all of the problems in physics, you've got to visually look in all four dimensions. So I invented the galaxy clock to include the third spatial dimension, depth, and to allow you to look at all four dimensions plus time, and maybe we could have a revelation. Now, when I put the search for the graviton on my clock, on the galaxy clock, I put your time forward particle, your positron, your proton spinning positive, and your antiproton spinning negative, and right away I found it would be impossible for the antiproton and proton pair to be on the same exact radial distance from the center of the wave, because they would collide in a single orbit, on a half of an orbit. They would both collide and matter would annihilate. So the only answer as to how they were not colliding and causing matter to annihilate would be that they would be on microscopically slightly different, smaller than a sub-Planck length radial distances from each other, which means in a galaxy clock you can see that one is slightly higher in frequency than the other. And that would mean there is a differential or difference between them. They would not cancel each other out to absolute zero. There would be this tiny force between proton-antiproton pairs and electron-anti-electron pairs called a differential. And that differential, when you run it through a Planck equation, that energy is equal to E equals hf, the frequency of the oscillation of Planck's constant, there is a leftover charge of energy. And that little guy, I propose, is the graviton. And that, the very fact that you can find this tiny leftover charge on the atom between particle-antiparticle pairs is such a weak charge that it would explain, firstly, why gravity is not a strong nuclear force. It's considered one of the weaker nuclear forces. If it was a strong force, we'd all be pulled towards gravitational bodies at the speed of light, and we would annihilate upon impact. Gravity is a very weak force in retrospect to electromagnetism and the strong nuclear forces. So, but if you could prove that matter has a weak electromagnetic, electrogravitic charge on it, and you can see where it is, then you can build wave generators to phase synchronize with that weak force, and you could manipulate gravity. Now, it would mean that you could also merge electromagnetism and gravity into the same theory, which would move us towards a TOE, a theory of everything. Now, the next thing that happens is that you find that gravity as we experience it is also a differential. It's a differential between centrifugal force, which is throwing out. We are, at the equator, our planet is spinning at 1,000 miles an hour, and by all logic, if you spin a pie plate and you put a marble in the center of it, it's going to throw the marble off the pie plate. That's centrifugal, throwing out. So everyone wonders, why aren't we thrown off the planet? Well, the counterforce, centripetal, gravitational pull, is pulling in, countering to that. But we experience a differential, the leftover between those two forces, centrifugal and centripetal. And that differential, I believe, is a reflection out of the quantum world, where there is a differential between particle-antiparticle pairs.
Well, if I could clarify one thing very quickly, and I could be mistaken about this, that's why I want to follow up on it. In your model, then, what you're really suggesting is that the graviton isn't a discrete particle, it's more of a discrepancy between waves or frequencies.
Well, particles are all particle waves, so they're all in wave-particle relationships all the time, and that's one of the things, for example, when you look at Einstein's four dimensions, don't see it like straight lines. See everything in those four dimensions as a wave particle. And then, of course, you could call the fifth dimension the observer. The observer is the human brain, which is also a wave particle, because we produce brain waves, and we observe only quantities of energy or electromagnetic interference on mass by the limitation of our brainwave state.
Sure,
so
a lot of
when
people...
you're talking about the graviton, you're talking about what I call the differential between particle-antiparticle pairs, which is what I believe the graviton is. It is a particle, but it's a wave. It's a small amount of energy that is so... I can see why they haven't found it. It would be so weak, because you consider how small the gap would have to be to allow particle-antiparticle pairs to pass each other, even smaller than a shell distance, that you wouldn't see it until we have this major breakthrough in the ability to look at sub-Planck length, with electron microscopes that are able to look at sub-Planck lengths, and that's just around the corner. Actually, there's a physicist here in Los Angeles who is making a major breakthrough in looking at those distances.
Sure. Well, a lot of people have been critical of quantum mechanics in that the model itself requires everything to be both a wave and a particle. It's actually a flaw in the model, especially in some cases when people consider gravity. And, I think one of the limitations has been the requirement for a graviton to fill the quantum mechanics model, whereas in relativity, there's never really an assumption that there's a particle there. It's always an assumption that it's the fabric of time and space. Now,
well, yeah, exactly. Now, the next thing that happens when you look at the subatomic model, the quantum model, of seeing that when particles increase in frequency, they're giving up their mass. I mean, just try to think this of like a washing machine, for example. You throw a sock in the washing machine and it's spinning, and the sock is thrown to the outer rim, which means if the sock is going to maintain an orbit closer to the center of spin, it has to throw off its mass. What happens in particles, or what I believe happens as we move towards our black hole in the center of the galaxy, is the same thing, is that the planets, when they start to get captured in higher frequency orbits around the black hole, the centrifugal force throwing out causes them to match with another wave that is trying to pull them in, just like the differential we experience for gravity on Earth between centrifugal and centripetal. Well, that causes a lot of heat to happen, a lot of friction on the throwing of the mass outward, and that heat eventually gives birth to photons, which give off or cause the particle to reduce its mass gravity effect, and therefore it becomes stripped of it. And the reason I believe black holes are devouring huge mass bodies, suns and planets and stars and gases, is because the mass gravity effect is reducing, not increasing in a black hole, which would eventually predict at the center of a black hole, if mass is reducing, as I say it is, to the point that whole planetary bodies are as light as photons in retrospect to the mass gravity effect, and the gravity is only effect. It's an illusion depending on the wave state of the matter, of the mass. Then at the center of the black hole, eventually you should be able to break the speed of light. And CNN reported, and this is at the end of my paper, that scientists have observed, and this has happened a number of times, what appears to be mass or a signal going twice or even 3 times the speed of light out of the center of a black hole. Now, when scientists saw this, astronomers saw this, astrophysicists were like, impossible. Einstein's law prohibits mass from going, even attaining the speed of light. It can only do 99%, 99.99%, and those nines just keep growing. Like I said, the more energy increased, the nines keep growing, but you can't attain the speed of light or even twice it unless the mass gravity effect is reducing. Now, if the quantum model says that the mass gravity effect is reducing as particles enter higher frequency orbits, then the galactic model has to be the same. You can't have one in disagreement to the other. So one of the two theories is incorrect. Now, Einstein assumed, I believe, that in our perspective of gravity and mass and our locale in the galaxy, which is we're in a much wider, longer wavelength in galactic terms, because we're 1/3 of the way to the center from the outer rim of our galaxy, and planets that are in higher frequency orbits around the galactic core or black hole would, in my theory, their mass gravity effect would be less. It would be lighter. But Einstein couldn't see that. He just assumed that mass and gravity are the same relative to mass as we experience it at this particular point in the galaxy. So I think what the CNN article shows, even though they tried to reverse their analysis, that they must have made a mistake, it couldn't really be doing 2 times the speed of light or greater, I think that they're wrong. I think that my theory, which predicts that mass gravity effect is reducing, is the only way to answer why these ejecta that are being observed out of black holes are breaking the speed of light.
Sure.
But that means that we can do the same thing with spacecraft. And when you look at all the theories, wormholes require the negative energy of 100 million suns for a wormhole with a snout wide enough to fit a quarter through, according to Kip Thorne at Caltech. That's the negative energy of every sun in our galaxy. There are 100 million stars in our galaxy. The energy they put out for a whole year to make one wormhole. I mean, it's ridiculous physics, but wormholes are beautiful if you consider the concept of reducing the mass gravity effect of the 2 points of space-time you want to fold. If you can transform just the locale of those 2 points, the mass and the locale, then you could do a wormhole on a wave transformational state. You could actually reduce the mass, and therefore the wormhole would cost you way less energy.
Well, David,
then you look at the idea of accelerating particles towards the speed of light. It takes 1 trillion electron volts of energy in an ion nuclear propulsion drive, and there are no nuclear fuels that can produce energy levels that high. Plutonium will get you 200 million electron volts of energy, which, if you could utilize that in propulsion, will send you very fast. I mean, you'll be doing, maybe 80-90% the speed of light, but you still have G-force problems to deal with, and you still have inertia.
Sure. Well, I'm going to stop you right there, because what I'd like to actually do is come back and touch on the propulsion aspects of this, how it's actually engineerable, in a second interview. So I think for the time being, thanks again for your time, and I'll stop this one, and then we'll pick this up in interview number 2 with David Sereda.
Thank you, Tim, for